Here's section 11.4. And basically we've done all this work in probability. We've done 11.1, which is the fundamental counting principle. Alright, and the best example of that one is you go to Chili's for the 3 for $10, and you get to have choice of drink from 8 items. You get an entree, choice of like 10 items, and I think you get an app from a choice of 6. So how many different ways are there that you can go into Chili's and get a meal? And it's just 8 times 10 times 6, which is 480. Okay, so that's pretty straightforward. We're going to use that here in just a second. And then we did combinations and permutations. I think we did permutations first, and 11.2 was permutations, and then 11.3 was combinations. And 11.3 is a good homework because they have a bunch of good problems right there at the beginning. Is it a permutation or is it a combination? And making sure that you know the difference between those two. And this is the one that place matters, and this is the one I just use the word choose. That if I'm going to choose 3 people out of a group of 12, and it doesn't matter who comes first. All right, if I'm going to an ice cream store and I'm going to get 3 scoops in my bowl of different ice creams, it doesn't matter which one comes first. Okay, so there's kind of a really very quick recap of 11.1, 11.2, 11.3. Now 11.4 is now we're down to the fundamentals of probability. Now I have all my stuff here. However, for some reason the video didn't record, and I don't have this file anymore because it's on my old computer and we're switching it out, and I will have it, but I don't have it right now. Okay, so here at the top of your page is a blob. Okay, so it's just a blob, and we're going to call that blob S. Okay, and so everything in this blob is something, and so let's put some things in here. Let's put in this person right there. I don't know who that might be. Let's put in this person. Let's put in this person. We'll make this one cheering. Yay! Okay. This one's playing soccer. This one's, I think, maybe in the band. I'm not sure. Okay. There's a person. We're just putting people in here, and there's a person. There's a person. Oops. There we go. Put a little volleyball in her hand. 1, 2, 3, 4, 5, 6, 7. I missed somebody who. Oh, put right here. I think this one plays softball. Okay. So there's everybody. And if you would say that this is the sample set, this is a set of people. Okay, so we've kind of used that terminology, a set, a group of people that are taking contemporary math this semester at Mineral Wells High School dual credit. Okay, and so what's the probability of choosing, let's see, let's say NS. We don't know who that is, Nicole. We don't know who that is. But what's the probability of me reaching into this? You guys are walking around randomly, walking around, and I am like a claw coming in there, grabbing somebody, pulling them out. You can think of all these people in a giant hat. That's a horrible hat. Anyway, okay. So the probability of drawing NS, well, how many times does NS appear in here? 1 time. Out of how many people are in here? 8. So probability comes basically down to this. So here's my unofficial definition of probability. This is unofficial. is the number of ways to win divided by the number of occurrences, or number of things that could happen. Okay? So I can't reach into this hat of people and pull out someone that's not in here. Okay? So I have to say, how many ways can I pull out NS? 1. How many people are in here? 8. Okay, and then here's the official, right? The number of ways the events happen divided by the number, or the cardinality. Remember that N is cardinality. How many things actually occur in the set? So next thing up is I want a 12-sided die. So in my sample space or whatever, in my blob, it's a 12. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Those are all the things that could happen. What's the probability of rolling a 4? Well, 4 only occurs one time out of the 12 things that occur in there. Piece of cake. The next one on there, here. The bottom problem, we could also write the sample space as this. We could do a roster method. 1, 2, 3, 4. Sometimes it works this way. 5, 6, 7, 8, 9, 10, 11, and 12. Okay, and so what's the probability that I'm going to pick a number greater than 4? Probably rolling a number greater than 4. Greater than. Well, how many numbers are greater than 4? You can just count them out. 1, 2, 3, 4, 5, 6, 7, 8 divided by 12. Total ways that total of different number of different ways that happen, which is 2/3. I think your homework requires you to simplify the fraction. However, if you have a nice little calculator, it should do that for you. And most calculators, if I go 8 divided by 12, 12, all right, it might go 0.66 repeating, then you hit some type of button, and it's going to put it back into a fraction. Almost all calculators do that. So that should be nice and easy for your homework. I'm going to add another one. No, well, just a second. Let's do this one. So page 11 now. We're on page 11 in your notes. So the sample space S for a fair 6-sided dice is 1, 2, 3, 4, 5, and 6. Okay. So letter A is the probability of a 2. Well, it occurs 1 out of 6 different ways. Alright, so B, a number probability of X less than 4. Less than 4? Well, 1, 2, and 3 are less than 4. That's 3 out of 6, which is 1/2. C, probability of X greater than 7. Well, there are no numbers greater than 7. So 0 out of 6, which is 0. D, the probability X less than 7. So they're all less than 7. That's 6 out of 6, which is 1. So this is very, very simple. The probability of an odd number. Well, 3 of them are odd and 3 of them are even, so that's 1/2. Now, there are a couple things that show up in your homework. Let's have 3 children. A couple has 3 children. All right. So what's the sample space for having 3 children? Well, the first one could be a boy, right? And the next one could be a boy, and the third one could be a boy. That's a possibility. The first one could be a boy, the second one could be a boy, and the third one could be a girl. The first one could be a boy, the second one could be a girl, and the third one could be a boy. The first one could be a boy, the second one could be a girl, the third one could be a girl. So those are all possibilities, right? The first one could be a girl, 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 and then a girl, girl, boy, and then a girl, boy, girl, and then a girl, boy, boy. Okay, now that's all that could happen. 1, 2, 3, 4, 5, 6, 7, 8 things could happen. And we're gonna pretend that it's a 50-50 shot for having a boy or a girl, and so those are the things that could happen. You could do heads, tails as well. So if you notice from our last lesson, 3 children is 2 to the third power is 8 possibilities. If you have 4 children or 4 flips of a coin, it's 2 to the fourth, so there'll be 16 things that could happen. So you create the sample space, what could happen, and so what's the probability of having 2 boys? So you'll have some questions like this. Well, that had 3 boys. This one's 2 boys. This one's 2 boys. That one's 2 girls, 3 girls, 2 girls, 2 girls, 2 boys. So it happens it happened 3 out of the 8 times. So there'll be some problems like that. I like those types of problems. I might put some of those on the test. Okay. Now, we move to page 12. Page 12. Alright, so there's this thing. So what we just did is a thing called theoretical probability. You can also call it formal probability. It's what mathematicians do, okay? However, there's also a thing called empirical probability. And that's like, we don't know, like, what's the probability of someone at our school wearing pink today? Well, we'd have to actually go and look at all the kids and see how many are wearing pink. So we have to actually look at it. So we're going to look at it. We're going to take a look at the data. And so the definition for empirical probability is the observed number of times E occurs divided by total number. So let's say you're tossing a coin 8 times and it heads comes up 6 times. So you watched them and you flipped the coin 6 times out of 8. So the empirical, the probability of heads would equal 6 out of 8, which is 3/4. Now the theoretical, the probability of heads is what you know. Well, it's 1 out of 2 times. So oftentimes the theoretical and empirical and theoretical probabilities aren't the same. This is what you observe. This is what you know. If everything's fair, this is what should be true. Now, what happens is they come and they give us a table. Okay, so we got male, female, okay, we got action, comedies, we got total here, and we have total down here. Okay, so there's this chart on page 12. Looks like that. There's 10, 9, 19 total, 17, 20, 37 total, 27, 29, 56. So what's the probability, ready, that if I go in there and it says this, What's the probability if I pick somebody at random that they like comedies? What's the probability they like comedies? Well, a total of 37 of them liked comedies, right? So 37 out of everybody, 56. So we really don't know what's the probability of people who like comedies, but it turned out to be 37 over 56. And I believe that's 37's prime. Yes? So it will not simplify. So there it is. Now you might have to go into a decimal answer for some of these. Just put in your calculator, round to where they say to do that. Okay, so you're going to actually use a table to find empirical probabilities. All right, we got one more example. All right, so here's our other example. So we have male, female, married, never married, divorced, widowed, total. So this is on page 13 of your notes, and hopefully I will get your notes to you. If you don't have notes, you should have notes. I'm going to try to post these notes. But once again, I got to get my computer back. Okay. So here's the question. A. What's the probability never been married? Well, how many people have never been married? Never married. 74 out of 242. Which came out to be 0.31. Okay, so just how many people were never married? Out of total. So most of these are pretty probability of male. Probability of male. Now this is not a column, this is a row. So there's 118 males out of 242, which came out to be about 0.49. Okay. Here's a couple things advanced. And we're going to get to these, but I just want you to kind of see some things that might be a little harder. What's the probability of male and divorced? All right. So think about that for just a second. There's 242 people. They're in a hat. They're all scrambled up in a hat. I reach a claw in there and I grab one person out and I look at this person. What's the probability that this person is both male and divorced? Okay, added a word, both. Do you understand that he has to be male and divorced? So he has to. There's only 10 of them in there. There's only 10 divorced males in the hat. So it's 10 out of 242. Okay, now watch this. And this is just where we're going. Male or divorced. Okay, so the question is now changed from male and divorced, which is just those 10 people right here. They're the only ones that are both male and divorced, to male or divorced. Well, that would be all the divorced people, right? And all the male people. Male people? Okay, but look. That's 118 and 24, but look, I counted that 10 twice. So I can't do that. So it's going to be 118 plus 24 minus 10 over 242. Which comes out to be 132 over 242. Now that's a harder one. It's harder for people to see this, that, hey, wait, here's the males, okay? 3, 10, 40, and all those are the males. And then the divorced people are right here, but I noticed that I counted that twice. So I can't count it twice. Okay, so I got to subtract it back out. And so that's where we're going with probability. That's it. All right, so that's 11.4.